Good morning, all of you, in the session of thermodynamics. In this session, we will discuss about properties of system. See, in mathematics, there are two terms. If this is your x, if we change x, that means x2 minus x1, right? If this is equal to 0 and x2 minus x1 tends to 0. What is the difference between these two? Tell, what is the difference between these two? Thermodynamics says that this is our dead state. That means there is no any process happening. That means there is a balance between system to surrounding. This may be balance, but process will execute. Process will execute, but this is balance, but no process will execute. That means dead state. So in thermodynamic equilibrium, process will execute. That means what is the change in property? It also always tends to 0, not equal to 0. That means it is unbalanced but very minimum. It is unbalanced with a very minimum unbalance. It is unbalanced but very minimum. That means process is very slow. That means process is very slow. If the process is very slow from point 1 to point 2, then we can say that equilibrium will exist. The word equilibrium implies a state of balance. That means a state is balanced. In an equilibrium state, there are no unbalanced potential or driving force within the system. That means if there is a system, if there is a system at all point of the system, the temperature is uniform, pressure is uniform, volume is uniform. A specific volume is uniform. See, what is a specific volume? Specific volume, that means volume per unit mass. And we know that density is equal to mass by volume, right? If we write like that, 1 by mass by volume, 1 mass by volume, 1 by density. So a specific volume is 1 by density. See, a specific volume is the thermodynamic properties and density is the fluid property. Fluid property. In fluid mechanics, we have frequently used density, but in a thermodynamic, instead of density, we use So there is no any potential within the system. That means within the system there is no any transfer. With respect to property of a system. In a thermodynamics, there are three type of a property. What is that? First is the thermal equilibrium. If the temperature is same throughout the entire system, same throughout the entire system, that is the system involve no temperature difference, which is the driving force of heat flow. See, uh, if there is a system, if the system properties defined by a temperature, let's suppose T. This temperature will uniform throughout the system. That means within the system there is no any heat transfer. The pressure difference, the gradient force is flow. The potential difference, the gradient force is the gradient force is current. So these are the potential. These are the potential. That means change in temperature, change in pressure, change in volume. These are the potential. And due to this potential difference, the driving force will develop. That means if we change its temperature within the system, there must be a heat flow within the system. If we change the pressure within the system, there must be a flow of the fluid. If we change the potential within the system, there must be a current I. But according to thermodynamics, this tends to zero. Why? Because if there is a system temperature 20 degree, that means throughout the temperature is 20 degree, and if there is a surrounding degree, but obviously there is a heat is flow. Heat is flow. And finally, this system temperature come into the surrounding temperature, and after that it is dead state. Why? Because the system temperature and surrounding temperature are after some time are balanced to each other. But if we reject heat from high temperature body to a surrounding, the system temperature will change, right? But if the system temperature is suppose 90 degree, but when it is 90 degree, throughout the 90 degree, after some time it is 18 degree. When it is 18 degree, throughout the 18 degree, that means all the time the system property will remain same. That's why there is no any gradient or driving force in terms of heat within the system. Such type of a system is known as thermodynamic equilibrium. In a thermodynamic equilibrium, the property tends to zero. Why? Because the system will execute. In mechanical equilibrium is related to pressure, and a system is in equilibrium if there is no change in pressure, right? Already told that if there is no any change in pressure, if there is a change in pressure within the system, there must be a flow, and if there is a flow, there is an equilibrium condition. So thermodynamics will not allow that at any point of the system with time. However, see, this is very important. However, the pressure may be vary with the system with elevation. Suppose that if there is a elevation, because due to elevation there must be a pressure difference. In within the system there is a elevation, that there must be a pressure difference. But that due to that elevation, what is the pressure difference? This is very minimum, very minimum, very minimum. So we can neglect it. And this elevation, because however the pressure may vary within the system with elevation as a result of gravitational effect. So, but relatively very small. So, due to variation of the pressure, if there is any variation of the pressure in the system, it must be there is elevation because of the gravitation. But the pressure change developed due to elevation is very minimum. So we can neglect it. And in the case of mechanical equilibrium, delta P tends to 0. In chemical equilibrium, if the chemical composition will do not change with time. That means no chemical reaction within the system takes place. That means delta G Gibbs function is tends to 0. Right? So this is your thermodynamic equilibrium. Subject name thermodynamics. Chapter name Introduction to Thermodynamics. Topic name temperature and zeroth law. Welcome to all of you. Now, concept of thermal equilibrium. See, thermal equilibrium concept. See, we are trying to give you a practical approach. What is that? Suppose this is your system A of a property XA and YA, and this is your system B of a property XB and YB, right? And these two systems are contact with a adiabatic wall. This is your adiabatic wall. This is your adiabatic wall, right? That means two systems are contact with a adiabatic wall, right? Your adiabatic wall. Okay, and both systems are insulated. दोनों को हमने insulated कर दिया, insulated, right? That means there is no any effect to the surrounding. See, if we connect two systems by adiabatic wall, is the property will change or not? Here is the concept of adiabatic. Adiabatic. What is that? Adiabatic wall is the wall which will be sufficiently strong to resist any stress developed because of the unbalance of properties between the system A and system B. That means if the system A of a property XA and YA, if the system B of a property XB and YB, and system A property are different from a system B property, that means the system property unbalanced. Due to unbalance of a property, naturally these two systems try to achieve equilibrium, but due to adiabatic wall, this is a kind of a wall which resists the stress developed by the two system, it will resist. Generally made of wood asbestos. Asbestos that आपने देखा होगा asbestos, that means सिरामिक शीट्स होते हैं जो काफी सारे ऑन द टॉप ऑफ रूफ लगा रहता है. दिस इज जो asbestos, this is highly resistance, which is not allowed to heat transfer between the system. That means if there is a unbalance of a property, if this is your unbalance of a property, and due to unbalance of property there must be a heat flow, but due to adiabatic wall connected between two systems doesn't allow. Why the heat will flow? Because unbalance due to property, right? Now if we, this is a first experiment, and this experiment one concept adiabatic wall. Now if we take same system A of a property XA and YA, and system B of a property XB YB. Now we connect a dithermic wall. We connect a dithermic wall. This is your dithermic wall, and kept it insulation. Insulate कर दिया. This is your insulation. So dithermic wall is a kind of wall which is made of metal. This is made of metal. Due to metallic property, the unbalanced stress will develop due to unbalance. Stress will develop due to unbalance its property. There must be easily flow of heat from one system to another system, and finally these two systems will come into equilibrium, right? So yes, both experiment gives the concept of thermal equilibrium. This says that the equilibrium state achieved by two or more systems characterized by a restricted value of the thermodynamic properties. That means, see, if these two systems, if these two systems are characterized by a restricted value of thermodynamic property, there is a thermodynamic property. If those two systems are characterized by a thermodynamic property of the thermodynamic property of a system after they have been communication, that means you are adding dithermic wall with each other through a dithermic wall. That means you are able to understand that if we put the dithermic wall, there must be a flow of heat. If there must be a flow of heat, after some time the gradient which is responsible for flow of heat, the change of a gradient which is responsible of flow of heat, after some time it will zero. That means the gradient is what? The gradient is property. That means due to dithermic wall we can analyze that there is a flow of heat, and that flow of heat is due to change its gradient. And what is that gradient? There are a restricted value of a property. That means that is a property which is developed the driving force that gives the thermal equilibrium. That means thermal equilibrium simply say that the two systems are equilibrium by the restricted value due to flow of heat when they are communicated with each other by a dithermic wall. And what is the restricted value? What is the restricted value? We will see the next experiment. What is that? This is like that. See, if you put the dithermic wall, this two systems have a common property. One common property, right? Why? Because heat will transfer. So if heat will transfer after some time, these two body come into equilibrium. That equilibrium due to transfer of heat is known as thermal equilibrium. And if you do the next experiment is like that, this is our system A of a property XA, YA, and this is our system B of a property XB and YB, and these two are contact with respect to a adiabatic wall, right? If we contact with a third body C of a property XC and YC with a dithermic, this is your thermic wall, right? And put a insulation over there. This not isolation, isolated नहीं है, insulation, right? See, what your here conclusion is that, sir, X A system A is thermal equilibrium of system C, and system B is thermal equilibrium of system C. Why? Because we placed dithermic wall, right? Because we already understand that when we put a dithermic wall, there must A and C ये थर्मल इक्विलिब्रियम है, B and C ये भी थर्मल इक्विलिब्रियम है, because there is a adiabatic wall. But how you can say that system A is in thermal equilibrium of system B? You have a confusion. Why? Because you see there is a adiabatic wall, and adiabatic wall is a wall to resist the stress developed between the two systems due to unbalance of its property. That means here at this point you cannot surely say that the system A is in thermal equilibrium with system C. But yes, you can say that system A is thermal equilibrium with system C and system B is thermal equilibrium with system C. But you cannot say that system A is thermal equilibrium with system B, because the system A and system B are connected by a adiabatic wall. So for that, we try to analyze third experiment. After achieving the achieving the equilibrium, see what in our mind, these A and B have thermal equilibrium or not? Only one confusion, because we know that A and C are thermal equilibrium, B and C are thermal equilibrium, but what is it? A and B are thermal equilibrium or not? So we are spending some time, and after these two are equilibrium, next we connect system A of a property XA and YA and system B of a property XB and YB. See, and we put a dithermic wall. See, you put a dithermic wall and insulate the insulation is there. Insulation. See, if there is a unbalance between property A and B, after replacing the adiabatic wall, we insert in between A and B with a diadiabatic wall. The property of a diadiabatic wall is to allow heat between A and B, but after achieving equilibrium A with equilibrium C and equilibrium B is equilibrium C, we see that these properties doesn't change, though there insert a diadiabatic wall. That means if there is any unbalance between these property, to insertion of this diadiabatic wall, the property will change. But if we insert though they insert a diabatic wall, the property doesn't change. That means from here, that means we can say that we conclude that then the system property doesn't change. This information gives zeroth law. Then the this information कौन दिया? This information given by the zeroth law. और ये कह क्या रहा है कि when two bodies or a system are in thermal equilibrium with third one, then they are in thermal equilibrium with each other. That means when two bodies are in thermal equilibrium, body 1 and body B are thermal equilibrium with third one, body A and body B, that means system A and system B are in thermal equilibrium with third one because the diadiabatic wall. Then system A equilibrium with system B C and system B is equilibrium with system C, then automatically system A is thermal equilibrium with system B though there is separated by a adiabatic wall. This information is given by a 0. Due to thermal equilibrium, a property defined as a temperature. Thermal equilibrium concept of thermal equilibrium is given by a zeroth law, and zeroth law gives the concept of temperature. And what is the temperature? It is a thermodynamic property. See, this is the property that determines whether or not system is in thermal equilibrium with each other. That means it is a parameter to check that. It is a parameter to check that the system is in thermal equilibrium or not. Why? Because this is a property, and this property is sufficient to give the information about the two systems are in thermal equilibrium or not. That means if the two systems are in thermal equilibrium, the change of the temperature is zero. If there may be change of its temperature, that means there must be a unbalance between the property and heat will flow. Note, by replacing the third body, with a thermometer, if we replace body C by a thermometer, the zeroth law can be restated as zeroth law फिर ये बोलता है कि two bodies are in thermal equilibrium if both have the same temperature, right? Two bodies, अगर दो bodies हैं, two bodies are in thermal equilibrium, that means body A and body B. These are the thermal equilibrium. That means both have a temperature TA and TB. That means TA equal to TB. By replacing the third body with a thermometer, the zeroth law can be restated as two bodies are in thermal equilibrium if both have the same temperature reading. Both have the same temperature reading, right? Even if they are not in contact, right? Even they are not in contact, right? You see, when they are not in contact. So there are some fact is that the concept of thermal equilibrium gives the temperature. That means the zeroth law gives the temperature, and in zeroth law, third body, that means body C, act as a thermometer. Act as a thermometer. Okay. Thank you. Thank you very much.